One of the most important criterion or the hyperparameter in decision tree regression or classification is entropy. So I have pulled out a problem statement. Let us try to understand about the entropy calculation here. So based upon the outlook, temperature, humidity and windy, we are trying to predict whether the match will be conducted or not. So play is the target variable here and you can see yes and no, only two options, which means binary classification model. So outlook is categorical, temperature is categorical, humidity and windy are also categorical. But in windy, you can see like a false and true, might be like Boolean also you can consider, right? So how to calculate entropy for this? First look into this one and see how many yes, how many no are there. Exactly. 5 no and 9 yes. So I will just show you how to calculate entropy for this target variable. Right? So entropy is the measure of amount of uncertainty in the data set. How this is being calculated? Minus summation pi log to the base to pi. This formula you are supposed to memorize because they frequently ask in the interview, right? So what is pi? Nothing but probability, right? So let us now try to calculate. What are we trying to do now? Entropy of the target variable. In this particular data set, it is play. So let us now try to calculate that. So you can see that we have seen 5 no and 9 yes, right? Entropy 5 comma 9. Then entropy, totally how many cases are there? 9 plus 5 is 14. So 5 divided by 14 and 9 divided by 14. Then let us substitute in the formula. You can see minus 0.36 log to the base to 0.36. Likewise, let us calculate for 0.64 also. So once you do the calculation, you would be ending up with 0.94. So what we have done, we have calculated entropy for the target variable, which is basically play column, right? So in the same way, we are supposed to go ahead with the another column, that is independent variable and target variable also. So what I'm supposed to do now? I need to calculate entropy for outlook and play, temperature and play, humidity and play, windy and play. After doing that, what we are supposed to do? That we will come to that later. Okay. So step 1, we have calculated entropy for the target variable. What we are going to try now? For outlook and play. So let's see in sunny, how many yes, how many no. Likewise, in overcast, how many yes, how many no. In rainy, how many yes, how many no. Please pause the video. Just note it down in the piece of paper. Do the calculation simultaneously so that you can understand that. Right? So once we get the count, let us go ahead with the calculation right now, right? So what we are going to do now, play, match and outlook, correct? So we could see three different cases or three unique values under outlook: sunny, overcast and rainy. So in sunny, if you see that, how many yes, how many no. Likewise, overcast, yes and no. Rainy also, yes and no. So you can just note down the count. So total also you can see like a 14. Might be in some cases yes and no can be mismatching. If there is anything, please let me know in the comment. So let us proceed with that. Probability of sunny. How many sunny cases are there? 5 days. Right? So 5 divided by total number of days is 14 into entropy of 3 comma 2. This is nothing but formula. Okay, when we calculate entropy for target variable and independent variable, the formula is this, right? Probability of independent variable into entropy. So that's what we are trying to do. So probability of sunny into, we can see that 3 and 2. So that is written plus probability of overcast, right? Into here entropy 4 comma 0. So overcast you can see like a 4. So 4 divided by 14 plus probability of rainy. Rainy, if you see that totally 5 days divided by 14 into entropy of 2 comma 3, right? So how to calculate entropy, right? Entropy of 3 comma 2. How we need to calculate? Let us go back to the same formula, minus pi log to the base to pi, right? So in case if I'm doing for this one, what I'm supposed to do? Minus, right? First there should be minus pi, right? So 3 divided by 5 log to the base 2, right? Log to the base 2. Then pi, right? So that is what we are supposed to do. So let me repeat it. First, like this, you can calculate it, right? So what you can do? 3 divided by 5 and 2 divided by 5 you can calculate, right? So let me show you that. So if you see here, 3 and 2 are there, right? So we would be getting like 3 by 5 and another one is like 2 by 5. Why 5? 3 plus 2, right? So that's why 3 by 5 and 2 by 5. So 3 by 5, what do we get? 0.6 and 2 by 5 would be 0.4, right? So this is what we get over here. Then we are supposed to calculate the entropy. This is simple. Sunny told you 5 by 14. So this is what we are talking about, right? So what we are supposed to do? Minus 0.6 log to the base to 0.6 minus 0.4 log to the base to 0.4. So when you calculate this, you will end up with this 0.971, right? Likewise, plus the next case you can see like probability of overcast, totally 4, right? So 4 by 14. And then if you see definitely there is 0, so that is why it is ending up with 0. If you calculate also, you'll be getting the same. So likewise for the next case, rainy, you can see 2 plus 3, 5, 5 by 14, again 3 and 2, right? Like sunny, 3 and 2. So that's why definitely you'll be getting the same value. So we are ending up with 0.693, right? 0.693. So what we have done, step 1, we have calculated entropy for target variable, and then we have calculated entropy for target and one independent variable. What is the next step? We have done for outlook, right? What is the next step? We are also supposed to do it for temperature and play in the same way. Then humidity and play, windy and play, right? So this is what we are supposed to do it. So once we do that, we are supposed to calculate the information gain. What is meant by information gain? So let's go back to this one. Here for target variable, what did I get as entropy? 0.94. So what I'm supposed to do now? 0.94 minus, for the first column, that is outlook column, what did I get? 0.693, right? So once I do that, I'm getting the gain of 0.247. So likewise, now it is your turn. You need to calculate for temperature and play. Then you will end up with some entropy value. Subtract it from the entropy of the target variable. So check whether you are getting the gain of 0.029. So likewise, windy and play, humidity and play. So now compare all these 4 gains, which is nothing but information gain. Where the information is being higher, you can see that it is higher for outlook. So what is the purpose of entropy? There, the column which is giving highest information gain will be considered as the root node. In the same way, we can also do for Gini. But if you watch video on Gini, you are supposed to comment it. Then definitely I will be also making video about Gini, right? So far we have discussed about entropy, how entropy is helpful to select the root node. I hope this helps. Please like the channel, please like the video, and also subscribe the channel. That is very important. I know that many of you are watching the videos without subscribing the channel. Please do subscribe and share it with your friends. Keep learning, keep growing. Thank you.